Are you trying to add iOS 11 code to your project while still keeping compatibility with Xcode 8? If so, you're in the right place. Today, we're going to tackle how to handle conditional compilation in Swift. I totally understand how challenging it can be to manage different SDK versions in your projects. It can feel like walking a tightrope, trying to balance new features with older compatibility. You're definitely not alone in this struggle. Here's the specific question we're addressing. One user asked, "What's the Swift equivalent of Objective-C's preprocessor directive for checking if iOS 11 is available?" They want to ensure their code runs smoothly on both iOS 10 and iOS 11. Sound familiar? Let's dive into this. So what's the issue here? In Objective-C, you can use preprocessor directives to conditionally compile code based on the SDK version. However, in Swift, the approach is a bit different since Swift does not support preprocessor directives in the same way. And stick around. I have a great workaround for you at the end that will make your coding life a lot easier. To achieve similar functionality in Swift, the user can utilize the availability check in combination with conditional compilation. First, they should define a custom flag in their project settings for the iOS version they want to support. Next, the user can use the defined flag to conditionally compile code. This is done by wrapping the code in an if statement that checks for the availability of the iOS version. It's important for the user to remember that the availability check will ensure that the code runs only on devices with iOS 11 or later, while the conditional compilation will exclude the code from builds targeting earlier versions. Finally, the user should test their project by switching the base SDK in Xcode to ensure that the code behaves as expected across different iOS versions. Fun fact, did you know that Swift was introduced in 2014 and has quickly become one of the most popular programming languages? It's amazing how fast technology evolves. Now let's look at the answers provided by other users. An alternative solution provided by another user suggests placing the availability check outside of the function. You can use the @available attribute to specify that the function should only be available on iOS 11.0 and later. Let's take a moment to review another user's answer. This user suggests a straightforward approach for supporting both iOS 10 and iOS 11. They recommend setting the minimum SDK of your Xcode target to 10.0 while always compiling with the iOS 11 SDK. This way, Swift will help you catch syntax errors if you don't use the correct availability checks. For future compatibility, the user mentions using the /if can import directive in Xcode 9.3 with Swift 4.1. This allows you to check for the existence of future modules while still compiling your code under Xcode 9.3. Let's take a look at another answer from another user. One alternative approach is to define functions using the @available attribute. For example, you can create a function specifically for iOS 11 by using @available iOS 11.0. This ensures that the function is only available on that version and later. If you need to check availability within a function, you can use the ifAvailable statement. This allows you to execute different code based on the iOS version. For instance, you can handle iOS 11 specific code, iOS 10 specific code, and fallback for earlier versions. Here's the workaround I promised. Use the following code snippet to conditionally compile your iOS 11 features. This will keep your project compatible with older versions while allowing you to take advantage of new features. And there you have it. You can now conditionally compile your Swift code for different iOS versions. Remember, staying updated with the latest features while maintaining compatibility is key. If you found this helpful, hit that subscribe button for more tips.